A round balloon of radius r subtends an angle alpha at the eye of the observer, while the angle of elevation of its center is beta. Prove that the height of the center of the balloon is r sine beta cosec alpha by 2. So you see here, this is the balloon. This is a balloon. The radius is r. So radius of the balloon is r. Now there is a person standing here. He's looking at the ends of the balloon, the top of the end and the bottom of the balloon. When he looks at the thing from here to here, the angle he measures is alpha. That is the angle subtended by the eye of the observer. So angle subtended by the eye of the observer is alpha, while the angle of the elevation of its center. Now this is the center of the balloon. If you look at the center of the balloon, the angle made is beta. That is because it's looking upward, it's an angle of elevation. So angle of elevation at its center is beta. Now we have to prove that height of the center of the balloon is, this is the center of the balloon, this is the height. That means you have to find OL. And this OL is given by R sine beta cosec alpha by 2. This is what I have to prove. Clear? So let us see how to do it. Now, so this is a question. Solution. This is a balloon. This is the center of the balloon. Ground level. This is a ground level, and P is a point of the observer, and this is the PX is the ground level. Yeah? Now he's looking at the top of the balloon. From this point P, he looks at the top of the balloon. And from the same point, he looks at the bottom of the balloon. Clear? So he's looking at the top, he's looking at the bottom. This angle, the angle made by the eye of this person, this angle is, so this, say it is the point of contact is A here, and the point of contact here is B, and this angle APB, this angle is alpha. That is the eye angle made by the eye of the observer is alpha. Clear? So this is the center to the point of contact A. This is the radius of the balloon. Clear? Now this is again the another radius. This is also R. Now you join the center. So if you see this, here this is the angle with the center. When you see there, if you look at the center of the balloon, here this angle is beta. Now we drop a perpendicular from the center. This angle is whole angle is alpha. So this is half of it, because this angle and this angle both are equal. Because these two angles are equal, so it should be half of the entire complete angle is alpha by 2. And the other part also, that angle also should be alpha by 2. How is it? Now you see, here we make use of little congruency concept. In these two triangles, this is the radius of the circle, and this is a tangent to this circle, and this also tangent. So tangent length from an external point are equal. Therefore, this length PA and PB both are equal, and OA is equal to OB because both are the radius of the same circle, and tangent is always perpendicular to the radius. Therefore, this angle should be 90, this angle should be 90. Therefore, SAS congruency, these two triangles are congruent. Because these two triangles are congruent, so these two angles must be equal. But it should be equal what? The total angle is alpha, so this should be alpha by 2. Alpha by 2. Okay. So you don't have to prove that, just you write it as alpha by 2. Okay. Now, this is the perpendicular distance from the center of the circle to the ground level. OL is the height of the balloon, height of the center of the balloon. Yeah. So in this figure, O is the center of the balloon, P is the eye of the observer, PA and PB are tangents from P. That is, PA and PB are tangents from P to the balloon. Angle APB, APB is equal to alpha, and angle OPL, that is, this is beta, and angle OPA, that is this angle, and OPB, that is this angle, both are equal to alpha by 2. So I just explained to you why it is alpha by 2. Now, see here, what is it in the thing we want? It is in terms of sine and cosec. So let us take the ratios as per this. So let us take sine alpha by 2. So if you're taking sine alpha by 2, I take this triangle, small triangle. So opposite is OP and hypotenuse is OP. Because what is sine? Sine is opposite by hypotenuse. So sine alpha by 2 is OB upon OP. But what is OB? See here, what is here? OB is R. So it will become R upon OP. OP is a length. So if you take this down, so you take this OP this side and bring this down here, it becomes OP is equal to R upon sine alpha by 2. 1 upon sine is cosec. So this becomes OP is equal to R cosec alpha by 2. So R is equal to the OP is this length OP is equal length OP is equal to R cosec alpha by 2. Now see it is in terms of sine beta. So let us go for a sine beta. Sine of this complete angle opposite is OL and hypotenuse is OP. So sine beta is equal to OL upon OP. OL is equal to OP sine beta. Take OP this side, OP sine beta. But OP is what just now we have found it. OP is equal to this. Let's put it here. So it becomes OL is equal to R cosec alpha by 2 sine beta. So this is the height of the thing. So see here, we got the same expression here. So this is what we wanted to prove. So height of the balloon, center of the balloon, the ground, vertical height it is. Thanks for watching. If you liked my way of explanation, you have understood, do share it with your friends. Subscribe for my channel for more such videos. Like the like, click on the like button and hit the bell icon. Clear?